Hi everyone. So in today's video, we will create a Streamlit app that will query the World Economic Outlook report from IMF using AzureOpenAI and Langchain. So let's get going. IMF World Economic Outlook document is a 200-page document that's released twice a year and gives some detailed analysis as to the medium and longer term trends in the world economy, and is perfect for the query app that we're trying to build. Okay, now let's step back and try to understand what makes an AzureOpenAI app a really powerful app. There are three major capabilities that are emerging that determines the usefulness and the utility of an LLM app. These are: first, your app needs to be able to connect to your data. LLMs such as GPT are generalist apps, so they are good for general tasks. However, if you'd like to leverage the power of the language model on your own data to get personalized insights out of your data, you need to be able to connect the LLM to your data. And secondly, the app needs to be agentic. There are inherent shortcomings to LLMs, such as the training cutoff date or lack of certain capabilities like arithmetic. In such instances, LLM needs to be able to use tools to interact with its environment, whether it's browsing the internet to extract latest data or use a calculator to address the shortcomings of less capabilities in arithmetic. And thirdly, the LLM needs to be aligned. There are ethical concerns with using LLMs for certain applications. We know that LLMs hallucinate, they are not deterministic. And tasks that require classification or regression type of tasks, such as sentiment detection, for example, might not be very good for using the LLMs for. In that sense, if we decide to use the LLM for certain tasks, we need to be able to validate their outputs, whether use a second agent to verify and push the LLM to systems 2 thinking to validate its own responses, or use another LLM, such as an open source variant, feed the responses to filter out and determine whether they are good for production use. And so we will start with addressing the first capability in this video. So we will connect GPT to an external data, such as a PDF document with the IMF Economic Outlook report. To do that, we need to actually address the first challenge, and that is LLMs have limited context lengths. Context length is the working memory of the LLM that determines the size of the input that you can feed into the LLM. So then how do we feed a PDF to a model like GPT and use its powerful capabilities to generate insights out of this document? To do that, we use a method called retrieval augmentation. And here is what we actually do with retrieval augmented LLMs. We kind of concluded that context length is the limitation of an LLM and determines the amount of data that can be submitted to the language model. To address that, what we do is we split our document into smaller chunks that can fit into the context length of an LLM. We then create the embeddings of these document chunks. Embeddings are the semantic core of any text. They are dense vectors that can be stored in a vector DB to do similarity search between different pieces of text. When we receive the prompt for the LLM, we generate the embedding of the prompt. We do a similarity search between document embeddings and the prompt. We find the most relevant parts of the document, most relevant chunks of the document, and then we feed them back into the LLM. So this is retrieval augmented generation. So we augment the generation by retrieving the most relevant parts of the document. Okay, now, so here is how we code this with VS Code. Okay, so these are the libraries we will need to execute on this code, and let's now run our Jupyter Notebook cell and see if everything works. Everything works fine. Then the next step, we will configure our AzureOpenAI API credentials and test our API connection before progressing with the next steps of coding. Our API connection seems to work fine. Next, we will ingest the document with PyPDF reader. Next, we read the PDF file and create a string by going over each page. Then we create our chunks by using Langchain's character splitter. We create chunks of our raw text that each of size 1000 characters that are overlapping by 200 characters. This is to avoid any information that falls into the chunking boundaries. So we overlap these individual chunks and create a list of strings. Creating the embeddings takes some time, so I'm running the cell. Next, I'm defining my LLM, which points to an AzureOpenAI endpoint. And finally, I'm defining my Langchain chain. This is a standard stuff chain. Next, I will quickly execute my cells and submit a prompt which will trigger my Langchain chain. It will do a semantic similarity search within my embeddings of the document stored in the ChromaDB, and here I'm getting a response, so this runs well. Next, I will turn this Jupyter notebook into a Python script that will be executed within a Streamlit app. Okay, now, so this is the Pythonized version of our Jupyter notebook. It has some tidying up work embedded into it. The rest is the same, so I'm also caching this using Streamlit cache resource method here, so that for each query, not the whole sequence of steps, including creation of embeddings, is not repeated. And yeah, so the rest is the same. I'm having a very minimalistic user interface here as well. Next is, let's run this within Streamlit and see what happens. So now I've launched my Python script within the Streamlit app, and it's going through all the stages we've gone over before, like retrieving the document, paginating it, and then splitting into chunks, extracting embeddings, storing them into ChromaDB, and finally being ready to respond to our queries. So let's see how this will go. So our app seems to be working fine. Our embeddings are stored in the ChromaDB in memory, and let's now ask a couple of questions to see how well this is working. Okay, so first question. When will the economy recover? So let's see our model's response to this. That's a good answer. Now, a second one. I'm going to get a mortgage to buy a house. Is it a good time? So this is pretty much all the code required to build such an app. We define our embeddings, our LLM of choice, and our Langchain chain, and embed everything within a Streamlit app. So I hope you enjoyed this, and see you in the next video.